Okay, so this is a continuation of the last video, but if you haven't seen this one or if I started from scratch, then this is attempted repair number 5 of the Bosch dishwasher, E24 failure. So what we're going for today, we've changed over the distribution valve previously and that just didn't work out, so that was that one. And based on what I've read, and I'll put some links, the suspect is now the circulation pump. And the reason for that is when the dishwasher fires up, it uses the pump to check for the amount of water, and if that's pulling the wrong current, then it trips and creates the E24. So where we're at on the teardown, I personally find it much easier to undo the main bowl from inside the dishwasher before you start, roll the dishwasher over, separate the struts at the 4 corners, and the easiest way for me on doing this is lift the lid, put this on the catch, lift the lid again and slide it down the side of this catch. That way you can pop those catches off for the springs. Put a cable tie on this side just to protect these wires, and what we're going to do is we're going to cut, and I'll show on the instructions in a moment, cut the NTC off, cut the earth off, probably just leave the main connectors on and wrap them back with cable ties, and we're swapping over a new harness. And the reason for that is on the old motor we've got these 7 connectors, which is the PTC, the NTCs, the motor drive and the heater. Sorry, not the motor drive. The motor drive's on the end. So this is the new motor. So here we've got the 3 for the NTC and 3 for the heater. So it's just a slightly different layout. So they've gone for 6 pins, not the 7. So this is the new pump. It's going to cost you about 250 Australian, maybe about 200 US, maybe about 150 pounds. And it's an upgrade. It comes with a great instruction manual, so we'll go through that as we go. So basically it shows the connections. It recommends, and I find this a bit interesting, cutting off the old harness here and here to remove all the 7 pins at both ends. Then with the end, well sorry, the 4 pins here and the 7 pins at this end, or 5 I think it is. And then on this next page, if you can see that, it says cut the earth wire, not at the loop, just in the middle. That's the earth that currently goes to the main board, or comes from the main board, and you feed in that new one. So yeah, it is the feed, it's the main earth feed to the main board. Super critical you get this right, and that's why in this instruction it recommends it must be done by a registered electrician. So then finally cutting the NTC and swapping those over, keeping the pinouts the same. So we'll give it a go. I'll take a video as we're going halfway through. I think I might use the NTCs first. What you do need, which they don't provide of course, is some wire cutters and some wire crimpers so that you can crimp those connector terminals down. You could use pliers, but it's a bit rough, and I'll be checking the continuity on those as we go. And the other thing I do and like to do is remove all of this wire harness. It is a bit of a pain. There's about 8 connections on it, everything from the flow meter, the main water solenoid, the solenoid for the salt and treatment, again the sensor for the treatment, and then down the bottom the connection to the aqua stop, and also pulling out the float switch, which I don't know about you, but I always find to be a pain getting that float switch out from the float. Okay, I'll get on that and put it back together and we'll see if it fixes the fault. Okay, so got all the old wire harness back together, just starting to push things back together. Put this centre drum in position, and you can see there the new connector and the new NTC connector. The crimping was a pain, probably wish I'd soldered it. And I've left the old connectors on. I just pulled them back from the end there, and I've left them on there just in case this doesn't work and I want to swap that pump back out. Same with the connector on this side. So I've taken my safety zip tie off, and now it's just a case of pushing that back together. Just put this cover back on. There's a waterproof cover. Okay, and now just keep that and push that up, and that'll go straight onto the lid clips. And then finally just check the position of the drum. One thing that always catches me out is this drain, this overflow drain. So I'll just get that in position and get this all back together and give it a try. Okay, now it's cycling through and filled the tank. loading the dishwasher. And the metal goes in. You can see that all good. I did have one problem just at the back there. I hadn't clipped in the power wire for the aqua stop, which is a little dilemma, but all looking good at the moment. Alright, I hope that helped somebody. It would have been great if I'd have found this about 2 years ago, but in the meantime, thanks for watching the videos and don't forget to subscribe. Okay, just for a last bit of bonus content, this is the disassembly of the motor. So you take these screws out, which removes this back cover off the rear housing, and that gets you into the motor assembly, which then pulls off like this, leaving the motor housing, the pump housing, which is clipped on to the main housing assembly, and you can remove those clips if you're careful. And then just having a look inside this housing, we've got the NTC and the PTC. So that's the temperature, negative temperature coefficient, and the heaters. So those green rings in there are the heater elements. It heats the water into the stainless steel enclosure. Inside here is some kind of pump housing flow. I'm not quite sure. This doesn't come out, so it's all been molded in as part of that assembly. I might try and get that out later. So I can whip that ring out, but there's nothing too exciting going on in there. And then to the active part of the pump, so the way this works, it's just spun by the magnets, the electromagnets running through into this, I assume, magnet inside there. And there's a seal. The seal drops out. That's just the seal between the stainless steel and the pump. And then I'll give it a go a bit later, but can't quite see how this impeller comes out. There is a nut on the end there, but that doesn't seem to turn, and there's nothing else to hold it. But what is interesting, or might be on yours, is this play on this bearing is a lot. So I'll just see if I can show you that. There you go. So you can see, even though it might float with the magnet, it seems the bearing is shot. So the pump still works. You can see there the magnet spinning the little bit of swarf off my desk, off my bench. But overall it seems not too bad, Nick. And that was the root cause of the E24. So thanks for watching. I'll stick that at the end of the video, and hope this helps somebody out to make the decision to replace the pump first time they get the failure, not like me 2 years later. Okay, thanks for watching, and don't forget to subscribe. Okay, so I'm not sure what I call this, maybe bonus content of the bonus content, but I think you'll find this interesting. So I did get this rotor out of here, so there's an O-ring at the bottom holding this little bearing in place. Come back to that in a minute. Sitting on top of the rotor is the actual magnet assembly. Two shafts, inside bearing and outside bearing, and sitting on that is the impeller. So that was clipped together, I think welded, and that's now in two pieces. Left hand thread on the end there, and then sitting between those two is the bearing assembly, which sits down in that housing there. So if we look at this, I think you might see in the video, can you see that hole? That hole is a fair shade of oval, and that is that loose on the shaft. Let me try and just show you, hopefully. So that loose on the shaft. So this motor had really done the duty. It had chewed out the outside bearing to an oval. It had chewed out the inside bearing to an oval. Not sure you can see that, but just the same, absolute massive clearance. Replacing both of those would fix it up. However, the inside one's easy to replace. The outside one, I couldn't get the motor assembly out without breaking this plastic ring. If you want to do yours, just get a screwdriver underneath the impeller from the outside, and if you're lucky, this whole assembly will pop out with the motor and the bearings. So it is rebuildable. You could fix it, and it's worth I don't know, 150 bucks, 200 bucks. These seem to be some kind of graphite. Not sure what they're made of. They don't sound very metal, and they look a little bit like graphite, but I can't be bothered to make one of those. And just on the pump side, if you're interested, on the back side of the pump, this rubber ring does just push off, so that's just pushed in. So if you have a leak in one of those, you could get a spare part, and that might get you out of trouble. On the inside of the pump, hope you can still see here, not too bad. There's this spinny ring, which is just pushed on, so that just popped off with a little bit of easing. And then there's the heater assembly, which again on some pumps might fail, so I might list that as a spare part. You might struggle to get that, so that's going to be sitting on there. This is going to be sitting in the middle, and you're going to have the whole impeller in the middle there, so you could just push this off. It is just pushed into a rubber seal there, and it is a complete assembly. So mine's in good nick. I just managed to ease that out. Okay, so there's all your pump components. If you're wondering whether your pump's playing up, it probably is, and it wasn't making a noise. So 13 years of service, 2010 to 2023. I'm pretty happy with that, and we'll keep going with the new pump. Thanks for watching the bonus. Don't forget to subscribe for the third time, and see you next time.